Morning students, welcome to the Science 1 class. Today we are going to study about the combination of many resistor in a circuit. This combination of resistor is known as system of resistors or grouping of resistors. Resistors can be connected in various combination. The two basic method of joining resistor together are resistor connected in series and resistor connected in parallel. In this following session, we are going to learn about the many resistors having different resistance value or connected in series and in parallel. Now let us see resistor in series. A series circuit connects the components one after the other to form a single loop. Series circuit has only one loop through which current can pass. If the circuit is interrupted, it means disconnected at any point in the loop. No current can pass through the circuit. Okay. So if you see the electric circuit, all the resistors are connected one after other. If any resistor is disconnected, what will happen? The current will stop flowing to other end. So that is why the current will not pass through the circuit. The other resistor also will not work. So this is the resistor in series. Here he can able to see the image. If one resistor fails, all circuit fails. Okay, see that in the second one the bulb is broken. Okay, so the current will not passes through the other end. So that other bulb also not glowing. In the first image there is no any problem in the circuit. Okay, there is no any disconnection, so that both the bulbs are glowing. Now let's derive the formula for resistance in series. Let three resistance R1, R2 and R3 be connected in series. So how many resistors are connected? 3 resistors. Let first resistor be R1, second resistor R2 and third resistor R3. Let the current flowing through them. We already know current is what? I. Flowing through in a conductor. So I, according to Ohm's law, the potential difference is what? V1, V2 and V3 across R1, R2 and R3 respectively. Not given. Okay, we already know Ohm's law. What is Ohm's law? At a steady temperature, the current is directly proportional to potential difference. We know the formula V is equal to IR. Here V, potential difference, I is current, R is the resistance. So we take commonly, so potential difference V1 is equal to I R1, V2 is equal to I R2 and V3 is equal to I R3. Why? Because there is a 3 resistor connected in series. So let's take that first one, second one and third one. The sum of the potential difference across the ends of each resistor is given by when you add the potential difference only. So V is common. V is equal to V1 plus V2 plus V3. Using equations 4.7, 4.8, 4.9 will get V is equal to I R1 plus I R2 plus I R3. This will take 4.10. The effective resistor in a series resistor which can replace the resistors effectively. So as to allow the same current through the electric circuit, let the effective resistance of a series combination of the resistor be Rs. So then we will get V is equal to I Rs. Okay, that is 4.11. Combining equation 4.10 and 4.11, we will get IRS is equal to IR1 plus IR2 plus IR3. So here RS is equal to R1 plus R2 plus R3. That is equation number 4.12. Finally, we will get RS is equal to NR. What is N here? N is the resistor of equal resistance and R is the connected in series. The equivalent resistance to NR, the equivalent resistance in a series combination is greater than the highest of the individual resistance. So here you understand that when a number of resistors are connected in series, their equivalent resistance or effective resistance is equal to the sum of the individual resistance. Next, we move on to resistance in parallel. A parallel circuit has two or more loops through which current can pass. If the circuit is disconnected in one loop, the current can still pass through the other loops. In this circuit, we can able to see it is not like a resistor in series. Okay, we have a three loops in the same line. So if one loop is disconnected, the wire is disconnected, then the other two ways are there to current pass through. So one resistor is not works, then other two resistor will work. Why? Because there is a more than one connection. So parallel circuits, if one resistor fails, circuit still works. If you see the image 1, there is a two bulb, okay, two connections are there. So the current is passes through, there is no any problem. So these two bulbs are glowing. In the second image, in the first one, the bulb is broken. So but current passes through because of the bulb broken, the bulb is not working. In the another bulb is glowing. Okay, why? Because there is an one more connection. Okay, so the current is passes through in that connection, then the bulb is glowing. In the next one also same. In parallel circuit, the one resistor fails, the circuit will still works. Why? Because there is a more than one loop. Consider that three resistors R1, R2 and R3 are connected across two common points A and B. When you see this circuit, we can able to see that three resistors are connected in parallel in between that two points A and B. The potential difference across each resistance is the same and equal to the potential difference between A and B. All the resistors having the same potential difference in between than A and B. This is measured using the voltmeter. How to measure potential difference? The instrument voltmeter. We have to measure potential difference. The current I arriving at A divides into three branches. Okay, different current flowing through in each branch is I1, I2 and I3 passing through R1, R2, R3 respectively. According to Ohm's law, you have I1 is equal to V by R1. Then you have take first equation and I2 is equal to V by R2. I3 is equal to V by R3. The total current through the circuit is given by I is equal to I1 plus I2 plus I3. Using equation this 3, we will get I1 is equal to V by R1 plus V by R2 plus V by R3. Let the effective resistance of the parallel combination of resistors Rp when I is equal to V by Rp. Why we are taking Rp? It is a parallel resistor. So combining equation 4.16 and 4.17, we have V by Rp is equal to V by R1 plus V by R2 plus V by R3. Then finally we will get 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Then we know that 1 by Rp is equal to 1 by R n plus 1 by R plus 1 by R. Finally, we get is equal to n by R. So, Rp is equal to R by n. Here, n is the resistor of equal resistance or connected in parallel. The equivalent resistance is R by n. So, the equivalent resistance in a parallel combination is less than the lowest of the individual resistance. When a number of resistors are connected in parallel, the sum of the reciprocals of the individual resistance is equal to the reciprocal of effective of equivalent resistance. Difference between series and parallel. Equivalent resistance, more than highest resistance, less than lowest resistance. Amount of current in series, current is less as effective resistance is more. Parallel, current is more as effective resistance is less. Switching on off. If an appliance is disconnected, others also do not work. In series, parallel, if one appliance is disconnected, others will work independently. Heating effect of electric current. Have you ever touched a motor casing or a fan which has been used for a few hours continuously? What do you observe? The motor casing is warm, right? This is due to the heating effect of current. The same can be observed by touching the bulb which was used for long duration for continuous drawing of current. The source has to continuously spend its energy. A part of the energy from the source can be converted into useful work and the rest will be converted into heat energy. The passage of electric current through a wire results in the production of heat. This phenomena is called heating effect of current. Devices like electric heater, electric iron, etc. Joule's law of heating. Let I be the current flowing through a resistor of resistance R. V be the potential difference across the resistor. The charge flowing through the circuit for a time interval. T is Q. The work done in moving the charge Q across the ends of resistor with the potential difference of is VQ. This energy spent by the source gets dissipated in the resistor as heat. Thus the heat produced in the resistor is H is equal to W, that is work done, and is equal to that VQ. We can take this VQ, H is equal to W, W is equal to VQ. So, relation between the charge and current is equal to IT. Q is equal to IT. that we know already this charge, you have to substitute in the equation number 1. What is equation number 1? It is H is equal to work done is equal to VQ. So H is equal to W is equal to VQ. Okay. In that you have to substitute the relation between charge and current. Okay. Then we will get H is equal to VIT. This one you take it as equation number 2. From Ohm's law, V is equal to IR. We already know V is equal to IR is Ohm's law. This one we have to substitute the equation number 2. Then we will get H is equal to I into RT. We can write this as 2I in there. So we can write it as square RT. This is what Joule's law of heating. So Joule's law of heating states that heat produced in any resistor is first one directly proportional to the square root of current passing through the resistor. So when this is happening, when the resistance and time is constant, the heat is what directly proportional to the square root of current passing through the resistor. And next one, heat is directly proportional to the resistance of the resistor. So here I and T is constant, I is current, T is time interval. Here third one is directly proportional to the time for which the current is passing through the resistor. Here current and resistor is called constant. So Joule's law of heating states that when a current I passes through a conductor of resistance R for time t, then the heat developed in the conductor is equal to the product of the square of the current and resistance and time. Applications of heating effect. Electric heating device. The heating effect of electric current is used in many home appliances such as electric iron, electric toaster, electric heater, etc. In these appliances, nichrome, which is an alloy of nickel and chromium, is used as the heating element. Why? Because it has high resistivity, high melting point, and it is not easily oxidized. Dear children, do you know why we are connecting a fuse wire in your home? This fuse wire is connected in series in an electric circuit when a large amount current passes through the circuit. The fuse wire melts due to Joule's heating effect and hence the circuit gets disconnected. Therefore, the circuit and electric appliances are safe from any damage. This fuse wire is made up of material whose melting point is relatively low. Filament in bulbs. In electric bulbs, a small wire is used known as filament. This filament is made up of a material whose melting point is very high. When current passes through this wire, heat is produced in this filament. When the filament is heated, it glows and gives out light. Tungsten is the commonly used material to make the filament in bulbs. Now solve problem 6. An electric heater of resistance 5 ohm is connected to an electric source if a current of 6 ampere flows through the heater. Then find the amount of heat produced in 5 minutes. Here an electric heater resistor is what? 5 ohm. Always resistance is measured in a unit ohm. Okay. This is connected to electric source. If a current of 6 amperes flows through the heater, now current is what? 6 ampere. 6 ampere of current is flows through the heater. What do you want to find? Find the amount of heat produced in 5 minutes. Given R is equal to 5 ohm, current is equal to I is equal to 6 ampere is given, then time t is equal to 5 minutes. But we want to convert this time into seconds. So 1 minute is equal to 60 seconds. So 5 minutes equal to 5 into 60. 300 seconds we will get. Okay. Next, amount of heat produced. We already know that Joule's law of heating, that is the formula to find the amount of heat produced in the heater. So H is equal to I squared or T. This is the Joule's law of heating. Okay, what is the I? I is the current. 6. So I squared, 6 squared into what is the resistance? That is 5 ohm. 5 into what is the time? 300 seconds. So substitute these all the values and multiply it. We will get finally 54,000 joule. H is equal to 54,000 joule. Next one, electric power. In general, power is defined as the rate of doing work or rate of spending energy. Similarly, the electric power is defined as the rate of consumption of electrical energy. It represents the rate at which the electrical energy is converted into some other form of energy. So, rate at which electric energy dissipated or consumed in an electric circuit. Here, dissipated means it's scattering in various direction wastefully. Okay. It is denoted by P. Power is denoted by P. SI unit of power is what? What is denoted as W? Power consumed by a device carrying an ampere of current when operated at a potential difference of 1 volt. So the work done to move the charge across the ends of the conductor is given below. W is equal to VI into T. W is the work done, V is the potential difference, I is current, T is time interval. So power P is equal to work done by time. What is work done? VIT divided by T. So T get cancelled. So that final value you will get that P is equal to VI. P is equal to VI. That is the formula for electric power. Thus, the electric power is the product of the electric current and potential difference due to which the current passes in a circuit. Next, consumption of electrical energy. Electricity is consumed both in houses and industries. Consumption of electricity is based on two factors. One is amount of electric power and other one is duration of usage. Electrical energy consumed is taken as the product of electric power and time of usage. For example, underwater of electric power is consumed for 2 hours, then the power consumed is 100 into 2 is equal to 200 watt hour. Consumption of electrical energy is measured and expressed to watt hour. Its SI unit is watt second. In practice, a larger unit of electrical energy is needed. This larger unit is kilowatt, as 1 kilowatt hour is otherwise known as 1 unit of electrical energy. 1 kilowatt hour means that electric power of 1000 watt being utilized for an hour. Hence 1 kilowatt hour is equal to 1000 watt is equal to 1000 into 60 into 60 watt second. Finally, we get 3.6 into 10 power 6 joule. Next, domestic electric circuit. First, electric power is generated by electric power station. They supply electricity to our homes through electric poles or underground cables. Electric wires reach our home through main supply. Here it has live wire and neutral wire. It is a red color insulation. It is called live wire or positive. Next, neutral is a black color insulation. It is a neutral or negative. In our homes, electricity is distributed through the domestic electric circuits wired by electricians. The first stage of the domestic circuit is to bring the power supply to the main box from a distribution panel. Such as a transformer, the important components of the main box are a fuse box and a meter. The meter is used to record the consumption of electrical energy. Fuse box contains either a fuse wire, a miniature circuit breaker MCP. The function of the fuse wire or MCP is to be protect the household electrical appliances from overloading due to excess current. The electricity supplied to your house is actually an alternating current having an electric potential of 220 volt. Both the live wire and the neutral wire enter into a box where the main fuse is connected with the live wire. After the electricity meter, this wire enter into the main switch which is used to discontinue the electricity supply. Whenever required, the main wire are connected to live wires or two separate circuits. The two circuits are 15 ampere current rating circuits and 5 ampere current rating circuit. 15 ampere current rating circuit which is used to run the electric appliances with high power rating such as air conditioner, fridge, electric iron, etc. 5 ampere current rating circuit which is used to run the electric appliances with the lower power rating such as tube lights, bulb, TV, fans, etc. What is the thing why it is used? It is a domestic circuit. A third wire called the earth wire having green insulation. Its one end of the earth wire is buried in the earth and the other end is connected to the metal casing of electrical appliances by using 3-pin plugs. This wire has green color insulation. This wire provides a low resistance path to the electric current. The earth wire sends the current from the body of the appliance to the earth. Whenever a live wire accidentally touches the body of metallic electric appliances, thus the earth wire serves as a protective conductor which saves us from electric shocks. What is overload? If too many electric appliances are used simultaneously together or too many electric appliances are connected to the same socket, they draw extremely large current from circuit. Due to this, the wire may get overload and fire may start. This is called overloading. What is short circuit? When live wire and neutral wire comes in direct contact with each other, they cause short circuit due to high current passing through wire. Wire may get heated up and may catch fire. How to prevent short circuit and overload? It is prevented by using fuse. What is fuse? Why it is used? Fuse is a device which is used in a circuit to prevent damages to the appliances and the circuit due to overloading. This fuse stops the flow of usually high electric current. Next, MCP. MCP is a switching device which can be activated automatically as well as manually. It has a spring attached to the switch which is attracted by an electromagnet when an excess current passes through the circuit. Next one, LED bulb. LED is an abbreviation used for light emitting diode. It is basically formed by merging P and N type semiconductor material. Make it very clear that LED is not formed using silicon or germanium as their basic material. Instead of that, we use gallium arsenide, gallium phosphide or its basic material. At the time LED fabrication, the reason to use these material in that these exhibit special property through which they emit energy in the form of protons rather than in the form of heat. Advanced 7 segment display. A 7 segment display is the display device used to give an output in the form of numbers or text. It is used in digital meters, digital clocks, microwave ovens, etc. It consists of 7 segments of LED is in the form of digit 8. These 7 LEDs are named as A, B, C, D, E, F and G. An extra 8 LEDs used to display a dot. Advantages of LED lighting. Long life. LED lights have an outstanding operational lifetime. Expectation of sometimes up to 10,000 hours. Energy efficiency. Today's most efficiency way of lighting with an estimated energy efficiency of 80% to 90% than conventional light bulbs. This means that about 80% of the electrical energy is converted to light. Eco-friendly. LED lighting is much more eco-friendly. LED lights are free of toxic chemicals. Most conventional fluorescent lighting bulbs contain a multitude of materials like mercury that are dangerous for the environment, whereas LEDs are 100% recyclable. Durable quality. LED lights are resistant to shock, vibration, and external impacts. They make great outdoor lighting systems for rough conditions and exposure to weather, wind, and rain. Next, LED television. Light emitting diodes, LCD TV, liquid crystal display. LEDs emitting white light are used in monochromatic black and white TV. RGB means red, blue, and green. First LED screen was developed by James B. Mitchell in 1977. In 2009, Sony introduced the first commercial LED television. Advantages of LED television. Brighter picture quality, thinner in size, uses less power, consumes very less energy, lifespan is more reliable. This is about today's class. Okay students, have a good day.